Okay, so our next concept to discuss is section 3.4, which is covalent compounds. Right. So we talked about how in ionic compounds, we have an exchange of electrons. Covalent compounds work a little bit differently. By the way, ionic compounds are between a metal and a nonmetal, or contain a polyatomic ion. Covalent compounds are between two nonmetals. So let's say that we have two chlorine atoms next to each other. All right. Previously, I had spent all of this time drawing orbitals, but really, as I mentioned, we only care about the valence electrons. And so we just kind of shortcut, especially with covalent compounds, to drawing dots around here to represent valence electrons. Right? So chlorine has 7 valence electrons. I'm just going to put 7 dots around each of these. All right. So we have these two chlorines next to each other. Each one is short 1 electron of a full octet. Right? But neither one really wants to give up an electron to let the other one fill that octet. So they say, all right, let's share an electron. So they share these electrons. Now, if we look at this, we have these 2 electrons that are shared between each of these chlorines. We've satisfied the octet rule for both chlorine atoms. All right. This line here that I've drawn represents a covalent bond. Covalent bond is shared electrons. By the way, it's one covalent bond represents 2 electrons. Right. So let's look at something. Let's look at a similar idea. Let's say that I have 2 oxygens next to each other. All right, oxygen has 6 valence electrons. I'm drawing them this way for a reason. All right, each one has 6. Let's share a pair of electrons. All right, so that now gets each oxygen up to 7 valence electrons. That's still not enough. So let's share another set of electrons. In doing that, we have made a double bond to make this diatomic oxygen. By the way, this is the most common form of elemental oxygen. It's O2, bonded just like this. Also, let me point out something on this. So we call this a Lewis structure, where we show lines to represent our covalent bonds. But we also show our unshared electrons on here. All right. So unshared electrons, or sometimes lone pairs, these are also called. So we could look at the oxygens in this compound and we could say that each one has 4 unshared electrons, or we could say it has 2 lone pairs. All right. Now, let's look at a couple of other examples. Let's look at nitrogen. Okay, 5 valence electrons. Share 1 set. That gets us to 6. Share 2 sets. That gets us to 7. Share 3 sets. That gets us to 8. So there is our diatomic nitrogen molecule. All right. Now, let's look at carbon. And to explain this, I'm actually going to show carbon. Actually, let's look at carbon and hydrogen both. because this is going to illustrate a point nicely. Okay. Carbon has 4 valence electrons. Hydrogen has 1 valence electron. Right. Let's form a bond between this carbon and this hydrogen. Right. That gets our carbon to 5 valence electrons. That gets our hydrogen to 2 valence electrons. But remember, hydrogen's actually completely fine having 2 valence electrons. That's considered a full octet. Okay. Let's share these. Let's share these. Let's share these. That now gets my carbon to 4 valence electrons. All right. Now, let's look at a couple of other common compounds. Of course, one of our favorites is water. Okay. Oxygen, of course, we're going to have 6 valence electrons. Hydrogen, we're going to have 2. Let's share these. That gets me to 7 on oxygen. Let's share these. That gets me to 8 on oxygen. And we end up with this compound. All right. Now, one last example with this, carbon dioxide. Right. Let's put a carbon here. Let's do our oxygen like that. Our other oxygen like that. All right, let's form a bond between carbon and each of these oxygens. That gets our carbon to 6. That gets each of these oxygens to 7. So we need to form an additional bond, and we get okay. Now, when we are trying to determine bonding in a covalent compound, we can actually, conveniently enough, follow some rules. And so let's look at a couple of different elements. Let's do bonds formed and unshared electrons. So first thing I'm going to do here is let's look at carbon. Carbon, for our purposes, is always going to form 4 bonds. It's going to have no unshared electrons. Right? Hydrogen, always going to form 1 bond, not going to have any unshared electrons. Now, we used chlorine as a specific example, but we can actually generalize this to all halogens, which we abbreviate with the letter X. X in chemistry does not mean any element, it means any halogen. Halogens form 1 bond, they have 6 unshared electrons. Oxygen, 2 bonds, 4 unshared electrons. Nitrogen, 3 bonds, 2 unshared electrons. All right, that's our quick and to the point. Now, let's talk about how we name covalent compounds. Right? So, ionic compounds, we mentioned, always have to come together in a certain ratio to cancel out their charges. That's not the case with covalent compounds. We've talked some about CO2, but we won't all. It's also possible for, just for example, for carbon to bond with a single oxygen. Right? Or maybe we could have the compound N2O. I'm sorry. I'm going to use NO2 for this, even though N2O is also an equally valid compound. Or we could have N2O4. actually, you know what? Let me do N2O also because it's going to make a great example. All right. And also we can include NO in this. All right. So for covalent compounds, we have to use prefixes to tell how many of each element are there. Okay. Here are our prefixes. I'm going to write them up here. We use mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6. All right. Now, in making an example of that, let's go straight to these two compounds, right? Because there's a little bit of nuance to the rules here. So let's look at this one, N2O. Okay. Nitrogens, I have 2 nitrogens, so I'm going to call this dinitrogen monoxide. This one, same sort of deal. It's going to be dinitrogen tetroxide. But let's look at these two. And I'm going to jump back to the CO2CO example because they're compounds you've seen and have probably heard of, right? Turns out that if the first element in a compound, there's only one of them, we don't use the mono prefix. So we only have 1 carbon first in this compound. So we just call this carbon. Then we have 2 oxygens, so carbon dioxide. This one is going to be carbon monoxide. By the way, I know I've only used oxygen for all the examples I've given. Second element in a covalent compound, in a binary covalent compound, you change the ending to IDE. So this one, same deal. This one's going to be nitrogen dioxide. This one's going to be nitrogen monoxide. Right, now, let's look at the compound, just for example, PCl5. That's going to be phosphorus pentachloride. Right. So that's how we name ionic compounds, and that's the end of section 3.4.